Okay. So I just went ahead and put up problem 9 because I think that's where we left off last time. But after we finish, if you guys have any questions from the homework, just let me know and I can pull that up. But once everybody's in, which I think we still have one more person, but we can go ahead and get started. So, as you can see, I very painstakingly drew my XY coordinate there, but obviously it's still a little off. So somebody tell me, either based on their paper or my drawing, where would f of 4 be? What would that answer be? Three? Yep. So remember, x is what's inside, and this one was a little easy because 4 is right here, so 4 and 3. All right, somebody else for f of 0. It's that one.
1.
Yep. Okay, so we got those two. And then what's going on with C? When we do f of x equals -2, what's going on there?
Would the x be 0?
The x. So we want to look at when. We don't want to look at when x is -2, because you're looking at here, right? So here the x is -2 and the y is 0. But here you're looking for the y part, right? So these two are x's, these two are y's. So when is y equal to -2?
-6.
There you go. So I guess if you wanted to say y is here, you could. All right, so somebody else, f of x equals 0. When's that going to be?
Would it be -2?
It would be. Okay, so that is that type. I took a cursory look at people's homeworks while they were last night, I believe. So it looked like most of you were doing pretty good with that. It didn't look like anyone really needed any extra time or anything, so that was good. I'm just grabbing the attendance real quick. While I do that, if you guys want to let me know if you have any homework questions. If not, I'll keep going with the problems, or the other ideas. We can go ahead and move on to section or chapter 3. But that's up to you guys. Okay. So what do you guys think? I put the teacher notes up on Canvas. So you have my notes from chapter 2, I think you have my notes from chapter 1 as well. If you don't, I can upload them. So do you guys want to continue with chapter 2? Someone let me know. Yeah, chapter 2?
Yeah, that sounds good.
Okay. All right. Okay, so if we look at number 10, we might get to chapter 3 today anyway, but we can finish this out.
I have a quick question about your notes on Canvas.
Sure.
So I have them pulled up like next to mine, but I only see them go to number 10.
For chapter 2?
Yeah, when you scroll down, it cuts off at the second page at number 10.
Let me take a look. If it did that, then I can take new pictures and scan them in again. But let me take a quick look. Yeah, you're right. It only has the first 2 pages. Not really sure what happened there, but I'll I will take new photos. So sorry about that. Not really sure why that was messed up like that. Okay. Thank you for bringing that to my attention. I will fix it.
Yep.
Okay. All right. So we're going to let P equal negative 0.48 T plus 71. And then they want us to rewrite the equation with the function name of G. So how do you think we would do that? Okay. So which variable can you tell me is acting like our X?
The T.
Okay. So if the T is acting like our X, when we normally write a function, we normally write what? F of X, right? Okay. So that's my little hint for you guys. What do you think we're going to replace next, and how are we going to replace it? If we want the function name of G.
The P.
Yeah, we're going to replace the P. How are we going to replace the P?
Well, that would be the f of x, or I guess in this case, f of g.
Well, remember, we're not going to do F of G because in this case, our X is T. So what do you think that G is going to replace? Not the X, but the
The
F. So it's going to be G of T equals your negative 0.48 T plus 71. And that's how easy that question is. So make sure when you're working through the problems on Pearson, there could be some times where the problems are really easy. You're not doing it wrong. It's just, that's how easy it is. Okay, so the next one says, find G of 117. And then what does that mean? Okay, so someone tell me how to do that.
you make the whole thing equal to 117. So like g, the function g equal to 117, and then you find t.
Do we have to find t? Where's the 117 sitting?
In your X spot.
In our X spot. So are we finding this portion right now? Or are we finding what this whole thing will be equal to?
Finding what the second half is equal to.
Okay, so how are we going to do that? We're going to take the 117 and put it in for what?
For t.
For t. Very good. Okay, so g of 117 equals negative 0.48 times 117 plus 71. Okay. And if you figure that out, I assume most of you will use your calculators. And you're going to get what? We're going to round to 2 decimal places. What did you guys get?
Negative 56.16 plus 71, which just becomes 14.84.
Yep. Okay. Now comes the fun part. We have to take this and we're going to translate it into a sentence. So, how do you think we can do that? So I can, go ahead.
When T is 117, P is 14.84.
Yep. So I'm gonna assume it has something to do with the PowerPoints. And the assumption of what the 71 means. So what's on my teacher notes is in 2017, but we would be adding that. We would have to figure out what the original, I don't want to just write down 2017 and not know. So it must have said somewhere, probably on that PowerPoint, T of 0 is at 1900. So that makes this in 2017, we're looking at your 14.84% of American adults smoke. Okay. All right. So my whiteboard's a little small, but it was the best I could do at home. So when you guys are good, we can switch to C. Wow, you guys have so many faceless participants today. Must be because we have a 3-day weekend coming up. All right. So, am I good to erase A and B so we can get the rest of the problems down? All right. I guess if you need me to, I'll write. I'll fix this part. So this is going to be a G of T, and we know that was a P for percent. Okay. Okay. So for C, we want to find T when G of T is equal to 30. And then the same thing, we have to translate that into a sentence. So what do we have to do there?
You would make 30 equals negative 0.48 t plus 71.
Yep. Okay, and then
And then
mm-hmm.
I guess we'd solve for t then from
Yep.
here.
Yep. Okay, so that would be what, a negative 41? Then we're going to divide by a negative 0.48. So what does t equal? Round to 2 decimal places.
Um, 85.416 repeating.
So we'll round up to 42. So if we put that in English, we need about 85 years from 1900, right? So how are we going to write that in a sentence? Okay. Who can put it into a sentence for us? Can we all see it? I promise the math does get harder. I just have to teach you all the lower, early chapters.
The year they're starting out at is 1990, right?
1900.
That's what I meant. So would it mean in 1985, 30% of adults smoked?
Yep. Very good. Sadly, now we would probably have to do a study on how many teenagers smoke. But... All right. So for letter D, it's wanting us to find the p-intercept of the model and break down what that means. So that one actually doesn't really involve any algebra, because we can get that one straight from the what? Straight from the
X,
function. So what part of this would be the y-intercept, or your b?
71.
Okay. So how would you rewrite that as a ordered pair? What has to go with our 71?
Is it 0,71?
It is. Good job. Okay. And that means in English, what do you think that means if we put that into words? Remember the year that we start at.
In 1900, 71% of adults smoked.
Yep. And you guys tell me, how true do you think that is?
It's
Pretty
pretty
accurate.
believable.
You think it was accurate? So in 1900, I know it's getting harder and harder to imagine 1900, but cigarettes were, so the economy was all kinds of different in 1900. A penny was probably roughly equivalent to, I don't know, like $100 today. A lot of people just didn't have a lot of money. They literally had a minimum wage of maybe like 5 cents. So this is an example of what we call a model breakdown. Okay. And what happens when you have a model breakdown is that even though the model works for a lot of the other predictions, so like here in 1985, we had 30% of adults smoking. In 2017, we had 14.84% smoking, which probably is a little bit off. We're not really gonna have 71% in 1900 because it's probably just way too high. So that's an example of a model breakdown. But regardless, as long as you got this part and this part, you would be good.
I have
Okay.
a question.
Yeah.
Where are you getting like the whole like the story part, like the in 1900s, like the smoking part, like?
It more than likely is on your Pearson PowerPoint for this chapter. A lot of the professors take the notes straight from the Pearson textbook. So there's probably an example within this chapter 2 that deals
Okay.
with the smoking sensation of that time period.
Okay.
I apologize, because normally what I would do is I would present the PowerPoint to you. I will be honest, I do not go through the PowerPoint slide for slide or word for word, but I would have put up the problem and then we would have worked this out on the whiteboard. So I do apologize for only giving you a little bit of the story.
No, that's okay. I was just confused.
Yeah, it's all right. And honestly, you can put almost any story to this. It wouldn't have to be smoking. As long as you have a percentage in years, you could make it like the amount of pets that people owned, you know, as long as it has some kind of connection between each other. Okay, so if we want to find the t-intercept, what are we doing to find the t-intercept?
You have to rewrite the function.
We have to rewrite the function. So we're gonna plug 0 in for the left-hand side. Oop, that's wrong. Okay, so we'll subtract 71. Okay, so then we get t equals what? Roughly. Round to 2 decimal places.
Um, 147.92.
Okay, and since we know it's years, we're actually going to round up to the whole year. So if we add 148 onto 1900, what year are we looking at?
$2048.
Not too far away from now. Okay, so in 2048, what percentage of Americans will smoke?
Uh, 0%.
Very good. Okay, now I don't know what kind of technology there's going to be in 2048, but my guess is if there's a way to smoke something, people are going to be smoking it. So this is another model breakdown. Any questions on those kind of application-based problems? We do have 1, 2, 3, 4, 5. We have 5 more application problems to do. They're all slightly different, but it's up to you guys if you would just want me to put them up on Canvas or if you would like the explanations with them. And then let me know when you're done copying.
Can we do like one more explanation?
Sure. Do you guys want to pick? We have 11 through 15 left. I can tell you that 12 is just finding slopes. So that probably wouldn't be the most beneficial.
I was gonna ask about 14, like with the linear models.
Okay. Are we good with what's on the board? Can I erase it? Yeah? Cool. Okay. So with number 14, I am not going to write this whole paragraph out. In fact, I'm pretty sure my entire board would be filled and I would still need to erase and write more. So I'm just going to read it. A driver fills her car's 12-gallon gas tank. So we'll write that one down. 12 gallons. And drives at a constant speed. The car consumes 0.04 gallons per mile. Okay. Let G be the number of gallons of gasoline remaining in the tank after she has driven D miles since filling up. So the questions are, is there a linear relationship between D and G? Okay. And then we have to find the other information. So here's my little hint for you if it were to be on the program. If you saw B, C, and D, or even if you saw this on a test, what would your gut tell you the answer is for A? What do you guys think? Do you think it's linear? Is there anything remotely looking like maybe there's a slope? Or a possibility of a slope?
I was gonna say like the possibility of the slope, like with the 0.04 gallons per mile, that would be like your X since it's consecutive throughout the whole problem.
Yes. So the answer here is yes, because the rate of change is constant, which the problem told you it was constant. It's negative 0.04 gallons per mile. Can anyone tell me why I put down a negative? I would assume most of you drive cars. So why would
There's less gas as you keep going forward, so there would be a negative slope to represent that there's less gas.
Very good. Okay. What can you tell me about the g-intercept of the model? And do you need the line to figure out that g-intercept? What do you guys know about the gas tank? Tell me what you know about it.
G is the number of gallons of gas remaining. And so you have a 12-gallon gasoline tank that drives at a constant speed. So would it be 12?
Yep, and if we put it in an ordered pair, it's gonna be 0, 12. Very good. Okay. And we kind of already figured this out based on A, but I almost always do these. I almost always find my answers early. Slope of linear model. Okay, so typically most people, when explaining it, would probably have just left the negative off up top, but I like putting it on because it makes sense for your application. So really, we're just gonna rewrite it. Okay. And if we put all of that together, if we put B and A and C together, what are we gonna get for our linear model for the equation? What is that going to be? What two variables are we working with?
Your G and D.
And so because we have a G-intercept, it makes sense that G will be outside. So G of D is gonna equal what? Now we just gotta put the slope and the intercept together. So what's that gonna look like?
Would it be the negative 0.4 and then the like your y? I forget the other one. Is it 12?
Right, but what do you need with the negative 0.4? What's your variable?
D.
Mm-hmm. And then your plus 12. Very good. So that's how you break that down. And I will put this with my phone so I remember to take the better scans for you. Okay. Does anyone have the printout for chapter 3? Yeah. Do you guys need me to share it? Or
Yes, please.
okay. Okay, so you'll have to let me know. If I share my screen, can you still see the whiteboard is my question. But we can go based off of the screen share if we need to. Hold on, let me find it. Okay. Okay. Comprehensive notes. Make them bigger. Okay, so can you guys still see the whiteboard, or are you only seeing the chapter 3 notes?
Only the
I see
notes.
both. I see both. One's just smaller than the other.
I only see the notes.
Okay, so
You
if
have
you,
to pin her video to see it on the side.
that's okay. If you only see the notes, then let me get my teacher notes up. Which is fine. I have no problems doing that. Okay, while I'm pulling this up, let me give you my public service announcement of, even though we don't have class on Monday, yes, I want you all to still enjoy your holiday weekend as much as possible with COVID. But if you find that you have downtime, getting ahead in your Pearson will definitely help you out. The other thing I'm going to do to help you guys out is I'm going to put up the exam. So we're working on the chapter 3 notes right now. You should be able to have a decent starting to your exam. And if you guys need anything, please Please don't hesitate to ask. I don't mind. Why is that the only thing on here? That's not okay. Oh, here we go. Whew, almost gave myself a heart attack. There we go. Okay. All right, so remember, if I'm screen sharing, I'm not seeing all your wonderful faces as much, so please keep participating. Okay, so I'll give you guys a few seconds to write, or a moment or so to write down the vocab. An inconsistent system is a system that has no solution because the lines are parallel, which means they're not going to intersect. And then a dependent system has infinitely many solutions because the lines are identical when solved for y. If you have any questions on either of those, please let me know. Don't feel bad if you're like me and you have to have those definitions next to you when you answer these questions. I can never really keep them straight in my head. Okay. 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 Are we all good with the vocab? Right now I have Gavin, Mackenzie, Cody, Teddy, and Angela. You're my representation. Okay, cool deal. So if we look at example 1, it says use graphs of W and M to predict when the life expectancies of men and women will be equal, where T is the number of years since 1980. Now this is probably something that would have been on the PowerPoint, similar to the smoking exercise. Okay, so we have our M of T, and it's 0.208T plus 69.86. And then we have our WT, which is 0.115T plus 77.44. So they want us to be able to figure out when men and women will be equal. So what does that tell you we need to find? What do you think we need to find?
An intersecting point.
We need to find the intersection point. So you can do that a few different ways. You can either set the equations equal to each other and find when T is, and then add it to the year 1980. You could graph the two systems. I'm pretty sure when I taught this in class, we chose to graph the two systems. But either way, this is really important for you guys to remember. It's not a confident answer because it's too far in the future. So it's saying that the year they're going to be equal is 2062. And that's just way too way too far in the future for any of us to really feel confident in that answer. Does that make sense to everyone? Okay. So remember, when you're working with the problems in the program, they will ask you to explain things sometimes. And honestly, those are sometimes the trickier parts of the problems. You can get all the math right and then just kind of fumble on the, the explaining. Okay, so 2 and 3, they wanted you to graph and then find the intersection points. I gave a little note down there that it's not perfect due to the highlighters. I thought when I was making my notes that making them colorful for the students would be helpful, but it really just ended up getting all kinds of screwed up. So we'll just go through the process real quick. You would graph your two equations on the same line and independently of each other, and then you just see where the lines cross. So for 2, the intersection point is at -1, -1, 2. But what do you notice for number 3? They're what?
Parallel lines.
They're parallel lines, so they're never going to have a solution. They're never going to cross. It's not like, a bajillion points down the road, 2 of them are just going to crisscross. It's just not the way it works. I'll give you guys a few minutes to copy that down. I don't want you to feel stressed.
Would you be able to go back up for a second?
Oh yeah, I didn't mean to slide it. Is that good? Is that good right there?
Yeah.
Okay. Okay, are we good to keep working? Yeah? Cool. All right, so if we look at number 4, our system is y equals 2x plus 1 and 6x minus 3 equals negative 3. So what you have to do there is what? Someone tell me the approach that I took and why I took it. Go ahead, Gavin.
I think that you you put y into do you put y over where it is in the second equation? 2x plus 1 into that equation?
Right, so I rewrote the second equation into y-intercept form. And when you do that and you write it in lowest form, you actually see that the two lines are what?
They're the same line.
They're the same line. So since they're the same line, you say it's a dependent system, which means you have infinitely many solutions. Okay. Okay. So there's a statement on the next page. It says, don't forget to do your checks. What do you guys think that means? I can tell you that we're talking about once you find your point of intersection. What do you think it means to do your checks?
Like plot it on the graph to check if the answer was right.
Okay, so if you chose to go graphically, you could make sure that it is on both lines. If you went algebraically, you want to make sure that it's a true statement for both equations, okay? Are we ready to scroll down? Or do you still need number 4? I'll take it as a yes. Okay, So do you guys want the whiteboard again, or do you want to just keep working off of the note page? You guys tell me.
I like the note page. I don't know about anyone else.
Okay.
I like the note page as well.
Okay. Okay. So someone walk us through number 5, because it's obviously up there. It's using a technique called substitution. So can anyone see what I did?
You multiplied what was in the parentheses, so you did 2 times 3y and then 2 times 4, and then you brought it down to the problem below you and then took your minus 5y equals 5 and plugged it in and then solved from there to get your answer.
Oh, for number 6. Yeah.
Oh, sorry, are we on 5?
Yeah. So if we look at either one, 5 and 6, they're both solving by substitution. So what you have to do is you have to take the equation of the first one, so the one that's solved for just one variable already, and then you plug it into the opposite equation. Once you get that answer, you plug it back into the original. Okay. If you guys need to see any of them worked out, just let me know, and I will, I guess, do it on the Zoom whiteboard if you need me to.
Could you try 6?
Sure thing. So with 6, what we had to do first is we had to get the x by itself. And we picked the first equation because, actually, you know what? Yeah, I'll just keep doing it verbally because I know some people are still writing other stuff. We picked the first equation because x is by itself almost. There's a negative 3y with it. So you have to move the negative 3y over to be with the 4. So you get x equals 3y plus 4. Once you have what x equals, you're going to plug it into the second equation for the x value. So instead of 2x, you're going to have 2 times the quantity 3y plus 4. Then minus 5y equals 5. Once you complete that equation and solve it for y, you then take your y and plug it back into the first equation, and that'll get you your x. Does that make any
Thanks.
sense, Joe?
Yeah.
Okay. Anybody else need any answers or any questions with substitution? Okay. Again, you want to make sure once you have your points, you want to make sure that they're true for each. What can you see is done with elimination? What's that process like?
I have a question about number 7 and 8.
Sure.
For number 7, how did you get 7x equals 14 under 3x plus 5y equals 11?
1 second.
Like, where does that come from?
Number 6 or 7?
7.
Are we looking on the left side or the right?
The left. That part, the 7x plus 4, or the 7x equals 14, where does that come from?
Okay, so it's kind of crappy the way I wrote it, but I didn't have a lot of space. So you have to look at the top equation, the 4x minus 5y equals 3. And then you're adding 3x plus 5y equals 11. So your negative 5y and your 5y cancel. And then you get 4x plus 3x, and that gives you 7x, and then 3 plus 11 gives you 14. So the point of that is so you eliminate the y value. Like you eliminate the y completely, and then that way you just get x left. And then once you have x left, you plug that into the opposite equation.
Okay. All right. Thank you.
Mhm. There are 3 ways to solve systems of equations. You can use graphing, substitution, and elimination. I suggest you practice all of them. I can tell you that there's a small loophole in the programming. Even if it tells you to use elimination or substitution, you could get away with using the opposite or whichever one you felt more comfortable, because all they care about is the point. But if it's for the quiz or the exam, I'm going to want to see you doing the actual request. But you can check a problem, any of these problems, by doing the opposite approach if you like one better than the other. So that's a really good way to make sure that you got it right. If you do the approach that you're more confident at, and then you have to do an opposite approach, then you just do the one you're more confident at, you get your answer, and then that way whenever you do the opposite approach, you know if you did it right or not. Oops.
In number 8, if you're adding why is it 8x minus 6y? Number 8.
Because in order to be able to do elimination for this one, you have to get one of your coefficients, either your x coefficient or your y coefficient, to be the same in order to eliminate them. So I multiplied the first equation by 2 and the second equation by 3. And then that was able to give me the same y but opposite signs so they can eliminate.
Okay, that makes sense. Thank you.
Mhm. I'm going to be updating your Canvas gradebook with your live Zoom points, I think either this week or this weekend. So if you want, I can also put them into your Pearson gradebook It's up to you guys. I can make sure that all of the grade books are updated together. So. Make sure you take note of number 9. Anytime you can do a shortcut like that, it will definitely save you guys like on exams and stuff if you can find your shortcuts.
I'm sorry, I'm asking so many questions, but number 10, is there any solving to do with that or?
So what we did for number 10 is we solved down just for y on the second equation. And in fact, I'm pretty sure it's a repeated question. I think that's what we figured out before. Yeah,
Oh, okay,
if
yeah.
you look at number 4, it's the same as number 10. I didn't make these, but
Okay.
we did figure that out before.
Can you just go over number 12 for me? I'm having like trouble following these ones.
Sure. Okay. So if we look at number 12, it says in 2012, a 2011 Acura RL cost about $37,120. And a 2011 Chevy Impala LS sedan cost about $14,050. The RL depreciates at $4,245 per year, and the Impala depreciates at $12,000 per year. When will these 2011 cars have the same value? So basically, you want to figure out when the RT, which R of T is your Acura, and then your IT is your Impala. So when do those two have an equivalent price? So the first thing you figure out is your equations. Your Acura is RT, R of T, and it starts out at 37,120. So that's basically your B for the Acura. And then it has a depreciation of 4,245 per year. So that's pretty much your slope. So that gives you that first equation of negative 4,245 T plus 37,120. Now you have to use a negative because it tells you that there's a depreciation. So it's not like when you buy a car, you drive it off the lot and you're going to make more money on it than when you bought it. Cars are not like homes. Sometimes you can make more money in a home if you have the right economical situations. That's not the case with cars. Cars would literally have to stop being produced for you to make money. And then the Impala, it has a depreciation of 12,000 per year, so that's a negative 12,000 T plus your initial price of $14,050. And then you just set them equal to each other and you solve for your T and you get 7.576. So that actually ends up equaling to this year. If you had those two cars, they would be about the same price. So 2020. And you just found that by taking and adding 8 to 2012. What you need to be careful with here is if you notice the two cars are from 2011, a lot of students could get confused and add your time to 2011 and get the year 2019, and then your program would tell you you were wrong. Now, I'm probably still going to give it to you because I could see that the only mistake you made was you thought that you should add it to 2011 instead of 2012. But ideally, you want to add it to the year you're actually talking about. Okay. All right. Anyone have any other questions? Okay. Before I let you go, I do want us to talk real quick about, I'm sure as all of you guys know, your, why is this not letting me stop screen sharing? Stop the screen share. Really, right now? How about I click this and I hit stop share? Okay. So real quickly, what I'd like to talk about is your homework on Pearson. I don't know what I was thinking when I gave the due dates, but they're really spread out right now. In comparison to what our notes are. Like we're halfway through chapter 3, and I think you only have homework due still from chapter 1. So I'm not going to obviously make all of your homework due tonight. That would be insanely rude. But I think what I am going to try and do is kind of scoot them a little bit closer, because I think once you turn in your exam 1, you shouldn't then still be working on chapter homework that's from exam 1. Like you should be kind of more paralleled to what we're covering in class. Does that make sense for everyone? Okay, so I'm not going to be a jerkwad and give you all only like 24 or 48 hours to get everything in, but you are going to see a shift in the homework because I do want it to line up more with what we're doing in class. I think I was just assuming that being online would be a little bit harder for us to stay like on point with how I teach, but for some reason, we're kind of still on the same pacing, which is actually really good from where I'm sitting. It means that when we get to the chapters that are a lot harder, where you guys might have, say, questions every single problem, we don't have to worry about a time sensitivity of, oh crap, we only have 3 classes to get through this. We'll have more like, say, 2 or 3 weeks to get through a harder a harder chapter, which is really a kudos to you guys for doing so well. So if you guys are okay with that, I am going to scoot some of the homework for these chapters up a little bit, because I do think some of you look at the due dates and then you don't really do anything until the due dates are closer, which I'm not putting that against you. I probably know if I had an open class, I would have just been done because I don't like dealing with homework. But I don't fault anyone for seeing that your homework isn't due and then waiting to do it. So I am going to scoot some of it. So if you see that scooting, don't be upset or anything. I I am also opening up some of the homework for students who needed it opened. I will do that immediately. Um, and then the only other question I have for you guys is typically I reopen up homeworks and quizzes if you are going to have a closed class, or, like over Thanksgiving break, if you want me to open up quizzes again, I'll open them up. So just, I guess, email me if you need me to reopen something, since we don't have class on Monday. Okay? All right. Thank you all for a great class. I will see you all on Wednesday, and if you need anything, just email. Okay. See ya.